While it's loading, right? Action time. Yeah, so we are live, right? We are live. While it's loading, right? So we're live. Action time. Yeah, so we are live, right? We are live. So let me just share this live to some places, and then we'll get the ball rolling. Do we have anybody in? All right, yeah, we have some folks already in, as you come into the live, share the live to your class, to your group, to your class group on WhatsApp, Facebook. But I know young people don't really use Facebook now. TikTok, Instagram, wherever you're sharing. Share it so that, let everybody know we're live and we're ready. All right, as you come in, tell us where you are, which school you're from, and how you did in the first mock exam. Let me just share the live to some places. So we're going up until midnight. Let's see who will survive up until midnight or after midnight. My fellows, my students, how we feeling? How we are thinking I'll make it until midnight? Who's making it with me until
No,
midnight?
sir, midnight, sir. I have to sleep.
Okay. Sleep is temporary, maths is permanent. You have heard that saying?
I wish never hear it again.
Anyways, folks, how how we are feeling? We have the mock exam is in 9 days. The actual CSEC mathematics exam is in the first paper is in 66 days. How are we feeling? How are we feeling? Students on the chat, on the call, on the live with me.
Nervous.
Nervous?
Yes, very nervous.
Nervous. All right. So I think I shared it in the early places. Good. I think I shared it in all of the places. Good. So let's go, folks. Let's get the ball rolling. These questions were chosen by the students that you see right here on the live. They ran through the past papers and they selected the questions that they thought would be best for us to work. Probably areas that most students tend to struggle with. So those are the questions that we will be tackling today. So yeah, so let's go. So we have 211 portions so far. So let's head straight into the questions. So the last time when we began this live, we looked at mainly the first like 5 questions or so in the paper, 6 questions. So for this paper, we will mainly look at the latter half of the paper. So we will start off with number 4 and number 4 question, which is geometry. And let's head straight into it. So this part, I did a video on TikTok the other day, and I said that number 4, I classify question 4 as the easiest thing that you can find on the CSEC mathematics paper. There's a reason why, because if you practice these here over and over, you will realize that there's a pattern and they don't really change any things that they ask, just that they ask it in different forms. So the first question says lines L and M are drawn on the square grid below. And we have line M and we have line L. It says write down the coordinates of the x-intercept of line L. So we have x-intercept and we have y-intercept. X-intercept is where the line crosses, obviously, the x-axis because it's talking about x-intercept. So they want the coordinates of the x-intercept for line L. So we have line L here, and the coordinates for where line L crosses that axis. We see it crosses right here. So that coordinates would be, we go 6 across and 0 up or down. So that would be 6, 0. Nice and easy. 1 mark there to get the blood flowing on this live. All right. So that would be the coordinate for the x-intercept. And the next one, they want the coordinates for the y-intercept of line M. So y-intercept obviously would be where the line crosses the y-axis. We see this is the y-axis here. And where line M crosses the y-axis would be right around this point here. So we see that coordinate would be, we go 0, we don't go across anywhere. And then we go -2 times down. Where we go down 2 times, it should be -2. So this would be 0, -2. And that would be the coordinates for line M. Nice and easy, 2 questions too. So somebody's asking, what paper is this? So the thing is, these are random questions, not really random. These are questions pulled together by the students that you will see on the panel. Different questions. So it's not really restricted to a year. So let's carry on. So the next one says, so when I pull up the question, you can probably try to work it before me, and then see if you get the same answer. So I have this one. The equation of line L is, we have x plus 2y minus 6 is equal to 0. Find the value of k given that the point 9, k lies on line L. So they want the value of k, and they give us this line here. So the first thing you want to do, so we have the line x plus 2y minus 6 is equal to 0. So the first thing you want to do, you want to write this here in the general form for the equation of the straight line. All right, that will make it much easier to find the value of k. So we know the general form for the equation of the straight line. Somebody tell me on the line, what is the general form? Go ahead, Adir.
So y is equal to mx plus c.
Y equal mx plus c. And we know x would be the gradient and c would be the m would be the gradient and c would be the y-intercept. And x and y would just represent any coordinate on the line, any point on the line. So that is what we want. We want to write this in that form. So we'll carry everything over the equal sign and leave y alone by itself. So the first thing I want to take off would be this x. So we carry over this x, we'll have 2y minus 6 is equal to minus x. And then we'll carry over the minus 6. And when we take that over, it become plus 6. So you'll have 2y is equal to negative x plus 6. And then last but not least, we take over the we take over the 2. The 2 is multiplying the y. When we take that over the equal sign, it will do the opposite. So it will divide. So we'll have y is equal to negative x plus 6, all divided by 2. And this here is the general form. We can even rewrite this as y is equal to negative x over 2 plus 6 over 2. All right, but we can leave it as that. So we have the general form here. So they want us to find the value of k at this point. So we have the point 9k. So this here would be a coordinate on the line, and we know x and y represent this coordinate. So this 9 here is the x value, and the k would simply be the y value. So to find the value for k, we just substitute these two here into the equation. So instead of having y is equal to negative x plus 6 all divided by 2, we replace k with y. So this would be k is equal to, and we replace x with 9. So k is equal to negative 9 plus 6 all divided by 2. And negative 9 plus 6, that would give us, negative 9 plus 6 would give us negative 3 over 2. Hence, k is equal to negative 1.5. That is our value for k. So somebody saying y equal 3 over 2. Anybody got this answer in the chat? Anybody did this before me got this answer? How are we looking, chat? How are we looking? This one here might probably be the hardest type of questions you would see. The hardest question you would see in number 4. This one requires some amount of application. So the next one, find the equation of the line M, well, find the equation of line M in the form y equal mx plus c. So y equal mx plus c, we want to write the equation of line M. So let's go up back to line M. So we have a line M is here, and they want us to write line M in the general form y equal mx plus c. So earlier we learned that when we write in the equation of a straight line, all we need to do is find the value for m and the value for c. So m would be the gradient and c would be the y-intercept. C would be where the line crosses the y-axis. So let's go, line M we're dealing with. So we see, first of all, the y-intercept would be negative 2. So we know c is equal to negative 2. And the gradient now, we can find the gradient by selecting 2 points on the line. And then we can use the formula change in y over the change in x and find the gradient. Or we can simply use the formula rise over run when we have a nice graph like this. So rise over run, we can choose any 2 points. I'll choose this point right here, and I'll choose this point right here. So rise over run. Let's see how many times I have to rise to meet in line with this point. So I rise up 1, 2. So it'll be 2 over, and I run across 1. 2 over 1, which is the same as 2. So the gradient is equal to 2. The y-intercept is equal to negative 2. Hence, the equation of the line would simply be y is equal to 2, which is the gradient, x minus 2. And that is the answer there. So let me just recap this. Whenever you're writing the equation of a straight line, the important thing, the 2 things you want to include in this equation of a straight line: the gradient, which is m, and the y-intercept, which is c. The gradient, you can find the gradient by using the formula, the change in y over the change in x. Let me do that. So the gradient formula is y2 minus y1 over x2 minus x1. This is another formula that students use. So to use this formula, we just select any 2 points on the line. So I'll select these 2 points as well. So the coordinate here would be 0, negative 2. And the coordinate here would be 1, 0. So this here would be x, this would be y, this would be x, this would be y. This will be x1, y1, x2, y2. So I use the formula. So I'm using the formula instead of rise over run. All right. And see, you'll get the same gradient being equal to 2. So y2 would be negative 2 minus y1, which is 0, over x2, which is 0, minus x1, which is 1. So this will be gradient is equal to -2 minus 0 would simply be -2 over 0 minus 1 would be at -1. And these two negatives will cancel out. And then we have the gradient being equal to 2 divided by 1 is simply 2. So this is another way you can find the gradient, the same thing like rise over run, but the rise over run is nicer, quicker, especially when you have a nice even graph like this here and just count up and you count across any 2 points, any 2 nice points. So that would be the equation of that line. So let me copy that and bring that down for reference. So next one, show by calculation line M and line L and M are perpendicular. So when two lines are perpendicular, when two lines are perpendicular, can anybody, let me ask the chat, let me involve the chat now. Chat, when two lines are perpendicular, how can we tell? How can we tell when two lines are perpendicular? Let me give the chat some time to be involved. And then I'll ask Briseus to give us the answer. How can we tell when two lines are perpendicular? Let me see if anybody in the chat will get it. And then I'll give that person a big up. How can we tell when two lines are perpendicular? Anybody in the chat? Right angle? Well, in terms of thinking about equation of a straight line, we're thinking about dealing with equation of a straight line. How can we tell when two lines are perpendicular? One is a multiple of the other? No. One is positive, one is negative? No. They form a right angle. They are the same? No. They meet at 90 degrees. So yeah, they are 90. When a line is perpendicular, they meet at 90 degrees. But specifically, I'm speaking about when you're dealing with equation of a straight line. All right, so I see this name might give me trouble to pronounce. Let me call it since you got the answer correct. Lonely Reaper. They said the gradient is a negative reciprocal of the other. So for example, if we have two lines, line one, we have the gradient for line one and we have the gradient for the other. If the gradient for the first line is 2, and if this other line is perpendicular to this line, the gradient for the second line will be the negative reciprocal. Reciprocal means you flip it. You flip it and you change the sign, right? Negative reciprocal. You flip it, and whatever sign it is, you change that sign. So the line perpendicular to this would be 1 over 2, negative 1 over 2. And if you have another line, the gradient being equal to 3 over 5, and we say the other line is perpendicular, the gradient of that other line would be the negative reciprocal of this, which would be 5 over 3, well, negative 5 over 3. All right? Let me do also another one. So if you have the gradient of one line being -3, and we say the other line is perpendicular to this line, the gradient of that other line would be a positive 1 over 3. So that is a relationship between two lines, two gradients, when one is perpendicular to the other. So in this case, if they say line, show by calculation line M and L are perpendicular, we first take the gradient of line M, which is 2. So the gradient of line M multiplied by the gradient of the other line that we found earlier. Did we find that line? Did we find the gradient of the other line, L? Do we have the equation of line L? Actually, we do have that equation. So that equation is y equal negative x over 2 plus 6 over 2. I know this 6 over 2 will turn into 3. So the gradient here, the gradient here would be it's -1/2. So the gradient there is -1/2. So if you multiply the two gradients, so it's 2 times -1/2. We see this will work out and give us -1. And that is how we show that the two lines are perpendicular. All right, when we multiply the two gradients, our answer should be -1. All right, and how do we get that -1? By multiplying the equation of the gradient of the normal gradient multiplied by the negative reciprocal. That's how we can tell they are perpendicular. Our answer should always be -1. All right, let me ask another question in the chat. What is the relationship between two lines when the lines are parallel? What is the relationship between the gradient when the two lines are parallel? When two lines are parallel, what is the relationship between the gradient? And then I'll take Briseus to give us the answer. Let me see if anybody will get it in the chat. When two lines are parallel, what is the relationship between the gradient, their gradients? All right, so I see. Good. I see Raj. No, not Raj. Somebody had it just now. I see Lamar. No, not Lamar. All right, so yeah, I got some fancy YouTube names. Anyways, I see the person with the number 3. Yeah, correct. So, Briseus, what's the answer? How can we tell when two lines are parallel?
Sir, can you hear me?
Yeah.
Okay, so since two lines are parallel, they have the exact same slope, and since the gradient is the slope of the line, if they're parallel, they have the same gradient.
Yeah, excellent. So they have the same gradient, right? If two lines are parallel, that means they have the same gradient. So when two lines are parallel, same gradient. When two lines are perpendicular, one is a negative reciprocal of the other. So those are two key relationships that you should know as it relates to the gradient and parallel lines and perpendicular lines. Perpendicular, one is a negative reciprocal of the other. Parallel, the gradients are the same. Fair, it's key. So the last question says, line L and M represent the solution of a pair of simultaneous equation. Using the graph on page 11 here in this diagram, write down the solutions to the pair of simultaneous equation. So this question is going for 1 mark. That means it's very easy. And that is one thing you want to know when you are dealing with CXC questions. You look at the marks. The marks will indicate the level of difficulty. You don't want to have a 1 mark question and you're working 2-page of working. So let's go back to the graph. So it says they represent solution. So to get this solution to two lines on a graph, we just look at the intersection between the two lines. So right at the intersection, that coordinate will give you the solution. So right here would be the solution to this to these two lines. So we just take the coordinates where they intersect. So the coordinates would be 2 across, 2 up. So 2, 2. Hence the solution, we know this first 2 is x and this second 2 is y. So hence the solution to these two simultaneous equations would be x equal 2 and y equal 2. Since they intersect right at 2, 2. So x equal 2, y equal 2. And yeah, these are some challenging questions that you would find on paper 2 as relates to number 4. And I can see why these questions were selected. All right, they are challenging. All right, so if I would encourage everybody on the live to brush up on number 4. Go and select all the number 4s over the last 6 years or so, and you work through them. They are very easy. They follow the same pattern. Either they will tell you that the lines are parallel or they will tell you that they are perpendicular. And, you know, it doesn't matter. You just remember the rules and you're good to go. So we started off with those. Let's take things down a bit. After I work this one, I'll hand you over to some of the students to work. All right, I've been talking a lot. All right, I've been talking a lot, so let me work after I'm done with this one, and then we'll hand you over to them. So this one says using a calculator, otherwise calculate the exact value of 1 and 4 over 5 minus 1 over 3, all divided by 2 and 2 over 5. So number one questions, they are typically very easy. They give you, they start off very easy to get your blood flowing so that you can get some, they don't want to start off too difficult. Any good exam will not start off difficult. So this is why, you would find number one in CXC being easy most of the times. 90% of the times, or I should say 85% of the times. So what you'll do here, you simply just work on the top and then divide it by the bottom. When you have these kind of fractions, you can, if you are excellent with your calculator, you can punch in everything in the calculator, but if you're excellent with your calculator, you can punch in everything in your calculator and get the answer in one go. But I would always encourage students to work on the top piece first, work on the bottom if you have to, and then you divide the top by the bottom. So I'll punch in the top in my calculator so you can do it and get the answer before me. So it's 1 and 4 over 5 minus 1 over 3. That would simply give us 1 and 7 over 15, all divided by 2 and 2 over 5. So divided by 2 and 2 over 5. Hence, that will give us 11 over 18. All right, so I see lots of portions added in the chat. 11 over 18, lovely. So give yourself a tap on the shoulder. All right, give yourself a tap on the shoulder. Surprisingly, students perform very poorly in number one questions. A lot of students score 0. I don't know why. Probably overconfidence. They think of it as being too easy, so they don't go and practice them. But don't take number one for granted. That is where you want to maximize on your mark. So practice lots of number one. All right. So the next one says for 2 marks, a lot of easy marks here. So 1.5625 plus, and I punch that in my calculator, 0.32 squared. That would give me 0.1024. And when I add those two together, I'll get add that to 1.5625. That should give me 1.6649. All right, nice and easy. 2 marks. If this comes in your exam this year, I think you should be smiling from ear to ear because very basic stuff, right? Very basic. I don't think they'll be so nice. I don't think CXC will be so nice in 2026. Probably they may, you never know. You never know your luck. Y'all never know your luck, right? So let's say we don't, and I'll ask somebody to work this one out, this piece now that I'll add on. Let's say we're asked to write this answer correct to 2 decimal places and let's say 2 significant figures. Let's say we're asked to write this answer correct to 2 decimal places and 2 significant figures. Think about give some people some time in the chat to get the answer. In the meanwhile, who would like to work this one on the call? Which one of my students? Maya. All right. Maya, go ahead. Explain and work.
Okay, sir. So for 2 decimal places, we would count 2 numbers after the decimal place, which would be 4. So after the 6, sorry, is a 4, and 4 is less than 5. So we would leave it as is. So that will be 1.66. And
right,
2
excellent,
significant
Maya.
figures.
Yeah. So let me write back the number 1.6649 and 2 significant figures.
Yes, so 2 significant figures, you would start counting from the first non-zero digit number. So we have 1 and then 2. After the 6 is another 6, which is more than 5. So we add 1. So that would be 1.7.
All right, thank you very much, Maya. Well explained, well said. All right. Significant figures, we start counting from the first non-zero digit. Decimal places, we start counting from the first number after the decimal point. All right, important difference. Important difference that a lot of students mix up and forget. A lot of brilliant students, they get everything right on the paper and then they're gonna make a mistake in significant figures and decimal places. So don't be one of those students, right? Don't be one of those students. Significant figures, force non-zero. You start counting from the force non-zero, decimal places, force number after the point. All right, let me just throw another one on your boots. Let's say I have let me throw another two questions on your boots. Let's say I have 25. Let's say I have this number and I have 0.00093. Let's say I wanted to write these two numbers in standard form or scientific notation. I want to write these two numbers in standard form or scientific notation, whatever you want to call it. They're the same thing, right? I'll give people in the chat some time to drop their answer while I'll take somebody on the call to one of my students to explain this. Somebody's asking, so what you think will come in the mock exam? No, I don't know. I don't know what will come on the mock exam. I know the mock exam will resemble what a CSEC paper will look like. So if you want to be prepared for the mock exam, you practice CSEC questions, CSEC type questions. So, Rook one.
Sir, can you hear me clearly? Because my internet kind of bad right now.
Are we not hearing you too clear?
So,
Speak up a bit.
I can still work it.
Yeah, go ahead. I hear you now.
Okay, so since the number is below 1, we already know that our power is going to be a negative. So
Which one you working? This one here for us?
yeah, wait, it was 2. Oh, sorry, I didn't see it first. Okay, I'll work the first one. So we start and we count from wait, we count to the first. Wait.
So we had a number
Second one first. I didn't.
253,253,000, right? Is that number? So the point is here, right, Rupan?
Yes,
The
yes,
point is
sorry.
here. So what are we aiming to do when we writing numbers in standard form? Anybody can drop in and so let me see if anybody sent it in the chat. So I see. All right, I see lots of correct answer. So the point of writing a number in standard form, we want it will be some number multiplied by 10 raised to a certain power. All right, it's some number multiplied by 10 raised to a certain power. So standard form or scientific notation is the only time you will be troubling the decimal point. All right, that is the only time you'll be troubling the decimal point.
Yes, sir. Working now.
Go ahead.
Okay, so we will move 1, 2, 3, 4, 5 spaces to the left.
So why do we stop at between the 2 and the 3, the 2 and the 5?
Because the number we stop at the number below 10.
Below 10, yeah. And what is the other category? It has to be below 10. What else?
And I don't know the other category, sir.
All right, so it got to be greater than 1, but less than 10, right? So let me finish
For
it off. So the number has to be greater than 1, but less than 10. So it will be 2.53 multiplied by 10, and this power of 10 will depend on how many times we move the point. So we jump the point 1, 2, 3, 4, 5 times. This will be 2.53 times 10 raised to the 5th power. All right, the power is positive because we move in that direction. Or the best way to think about it, the original number that we started out with is greater than 1. So from the time the original number is greater than 1, the power will always be positive. All right, as opposed to this case, the original number is less than 1. So the power will be negative. So the same thing applies. We move the decimal point between the first two digits, or the first two digits greater than 1, but less than 10. So we jump 1, 2, 3. Many students would mix up and stop between the 0 and the 9, but we can't stop between the 0 and the 9 because 0.93 is not greater than 1. So we got to go one more step. So it would be 9.3 multiplied by 10. And we jump 1, 2, 3, 4 times. So this would be a negative 4 power. All right. And that is how you write numbers in standard form. Sorry, this comes every year for CSEC. It comes every year in paper 1, yeah? Comes every year in paper 1, and it comes every year in paper 1, and you never know. All right. Good. So let's move on. Let's move on. Now the floor is now open to now the students will take over. All right. So you have this question on screen. Who want to tackle this one? Don't worry. So I see Danielle, and then I know Adir first, and then Danielle. Go ahead, Adir.
Alright, sorry. So we see it's a rectangle triangle.
And I read the question so man. I
Yeah,
don't
yeah,
know.
yeah. Let me know if they don't read this question. We'll see. The diagram below shows the triangle PQR in which angle QPR equals 62 degrees and angle PQR equals 90 degrees and PR is 11 cm. So they already insert all the values already. So we could just go right ahead and answer the question. The size of angle PRQ, and the angle that they want us to find is angle R. So since we see it's a triangle, we know that the triangle sums up to 180 degrees. And we are given two angles, the 90 degree, which is 90 degree already, and the 62 degrees. So we just add those two angles and subtract it from 180 degrees. Yeah. And that should give when we add it, we get 152. And when we subtract it, we get 28. So angle PRQ is equal to 28 degrees. Yeah.
Good, very good, very good, very good, Adi. So here's the thing. Some students will look at this here and think that, oh gosh, they gotta use one of the ratios, either sine ratio, cos, or something, and then they go and do some fancy thing. But how many marks this question went for? 1 mark, right? So 1 mark would tell you that it's something easy. All right. 1 mark would tell you it's something easy. So we have two angles already, and we know it's a triangle. And as Adir said, the sum of the interior angles in a triangle would be 180 degrees. All right. Adir, the next one, side RQ.
All right, sir. So side RQ, so is a right angle triangle. We find it for missing side. So it's one of the two things we're using, either Pythagoras theorem or trig ratios. But in this case, we're using trig ratios. And so the trig ratios, the easy way to remember it is just by like SOHCAHTOA. where sine theta is equal to opposite over hypotenuse, and cosine theta is equal to adjacent over hypotenuse, and tan theta is equal to opposite over adjacent. So the next step that we could go and do is label the triangle. So the side opposite the right angle is the hypotenuse. Yeah, and we could use this 62 degrees and label the side opposite the 60 degrees as the opposite side. And obviously the
So think Adir. I think we lost Adir. So I think he was about to say this would be the adjacent. All right. So let me finish it for Adir. He was going excellent. Let me finish it out. Hopefully he'll come back by then. So we see we are given the hypotenuse and we want to find the opposite. So we look at the trig ratio that has the hypotenuse and the opposite. The hypotenuse and the opposite. So we see sine has the hypotenuse and the opposite. So we'll use the sine ratio. So we'll say sine theta is equal to the opposite over the hypotenuse. So we say sine in this case, we're using sine 62 is equal to the opposite, which is RQ over the hypotenuse, which is 11. So we see to find for RQ, we just take over the 11. This is nice and easy. It's divide and take it over multiply. So we'll have 11 multiplied by sine 62 is equal to RQ. Hence RQ would simply be equal to, when we punch that in our calculator, because you can't do these things mentally, 11 times sine 62, that would give us 9.7124. And I in the front of the paper, they tell you when you have these long answers that you should round it off to 3 significant figures. So you can say RQ is equal to 9.71 cm. So when you have these long answers, you round it off to 3 significant figures. That's the instruction that they give you in front of the paper. All right. 9.71. All right. Somebody say Adir or a farming. Don't know what that means, but okay. So that is that. All right. Adir, are you back with us? All right, Adir still. So that is that. So we enter some algebra now. We enter some algebra. Who want to tackle this one? I'm doing too much talking. All right, that person went already. Anybody would like to go? I see your hand where you went already, but all right, go ahead. Go ahead. Go ahead, Maya. Maya Undan. Floor is yours.
Okay, sir. So for this question, we have 2x cubed minus 8x.
So what are we
So,
doing? What are we doing?
sir, so normally, once looking at this, some people would think, oh, is it difference of two squares? But we have cubed. So that's not the case. So what we would do is find the common factor between
So we factorizing,
8x
right,
cubed.
Maya? I didn't think you read the part.
Yeah, so we have to factorize completely.
Good.
Sorry. So we pull out the common factor between 2x cubed and 8x, which would be 2x. And 2x into 2x cubed would be x squared. Minus 8 into negative 8x would be negative 4. Yeah.
All right, so this will go this negative 4. Good. So the answer is 2x you factor out 2x, which is the highest common factor, and you're left with x squared minus 2. When you're factoring out, it's like you're dividing by that factor. All right. So very excellent, Maya. Next one.
Sir, but we can factorize. We have to factorize completely.
Oh,
So
you're
that
not
can
done.
be further factorized because in the bracket it's the difference of two squares now because 4 is a squared number. So what we do is we rewrite the 2x and then we open two brackets and put x in the first one and x in the second one, plus and minus. And then since 4 is a squared number and 2 squared is equal to 4, so we put 2 in both of the brackets. And that is our final answer.
All right, excellent, Maya. Excellent. Nice. So some persons would have left it here and they probably would have lost one in the mark because it's not completely factorized as yet because we see we have a difference of 2 square. All right. So just be careful. Look at the marks as well, right? Look at the marks. You see this here? 2 marks. So CXC would never give you a simple distributive law in reverse type factorized question for 2 marks. All right, they wouldn't, right? If you have a simple thing like if they give you something like let me just make up something 5x squared y plus 10x, and then you factorize this, you end up with 5x open bracket xy plus 2. This here would be a 1 mark question because you can't take it further. But you see these 2 marks here, that tells you, you want to think twice about what you're doing. So you want to be careful with these kind of questions, right? Just look at the marks. The marks will tell you the amount of work that you have to do. Right? I probably would have, if I been a student, I probably would have stopped right here as well. And you would have gotten probably 1 out of the 2 marks. Right? So you don't want to leave anything. You don't want to give back your marks at CXC, so read it carefully. All right, Ma, you're taking this one as well?
We have 3x squared minus 5x minus 2. So to factorize this equation, we would have to use the AC method. So A in this equation would be positive 3, B would be negative 5, and C would be negative 2. So AC would be equal to 3 times negative 2. And that would give us a negative 6. So we then find the factors of negative 6, which would be 1 and 6.
What kind 1 and what kind 6?
Sir, a negative and a positive.
Which one is negative? Which one is positive?
Sir, it doesn't really matter.
All right,
Because
negative
how
1
I
times.
do it, yeah.
Mm-hmm.
And that would be negative 5. Yeah.
Negative.
And yeah, that would be a positive 6.
So negative 1 plus 6 would give us what?
Yeah. Negative 5.
So it does matter, man. It does matter. So we need a negative 5, right? So
Yes, sir.
it does matter which one is positive, which one is negative, right? So which one you put in positive, which one you put in negative?
Sir, we put in the positive 1 and the negative 6.
So we can say negative 6 times 1 will give us negative 6. Negative 6 plus 1 will give us negative 5. So why is this negative 5 important to get though?
Sir, because it has to match the B value.
So we need to find B, right? So a nice way to think about this here, you don't use A, you don't use C. We gotta involve B somehow. So we gotta add the 2 numbers to give us the B so that, we involve everybody to the party. Yes, Maya, continue.
Yes, sir. So since we already find the factors, we have to put it into. So we write back the 3x squared, and 5x now would be equal to what we just did, which would be negative 6x, negative 6x plus x minus 2. So we put that into two brackets now, and then we factorize. So the common factor between 3x squared and 6x would be 3x. So we put the 3x outside of the bracket. 3x into 3x squared would leave us back with x. And 3 into 6x would give us 2.
That'll be minus 2.
Yeah, negative 2. And the common factor in the second bracket would give us 1.
So positive 1, right? Whatever sign is in front, you follow that sign. So
Yeah. So, yeah, so 1 into x would leave us with x. And negative 2.
good. So how can we tell that we're going correct though? What is one way we can make sure that we're going correct, especially at this step?
So the two brackets must be the same.
These two brackets have to be the same. If they're not the same, the signs are different, something is different, you know, you did something wrong, right? So two brackets should be the same. Yes, finish it off now.
So we just have to put back what's in the bracket. So that would be x minus 2. And we put what's outside of the bracket in one bracket.
3x plus 1.
Yeah.
And we got our 2 marks there. All right, we got our 2 marks. So well done, Maya. Excellent, Maya. All right, excellent, Maya. So somebody saying they put down the search party for Adir. So I think the search party work. Adir, are you back?
Yes, sir, back.
So Adir, you're aura farm until you know, you got kicked out. Too much aura for the YouTube.
Yeah,
Anyways, these kids. All right, so that was that, right? Excellent, Maya. W Maya, lovely. So I see Brandon has his hand up. Mr. Waddle, you want to work the make C the subject?
Yes, sir. I would like to try this one.
All right, let me write back the equation. So F is equal to 9 over 5C plus 32. Go ahead.
Okay. So since we have to make C the subject of the formula and it's F equal 9 over 5 C plus 32. So the first thing we would have to do here is to isolate the term with a C. And to begin isolating C, we need to subtract 32 from both sides. So in this case, we have F minus 32 on the left side is equal to 9 over 5C plus 32 minus 32, which would be 0.
All right, so that cancels. So we just take over the 32. It's adding and we take it over to the subtract, right? So it becomes F minus 32. Good.
Good. So to make C to be by itself, I think the next thing we can carry over is that 5 on the right-hand side, which in it is dividing by a 9. So to take over that 5, it would be multiplying. So what we can do is put the term on the left in brackets and put the 5 outside. So we'd have 5
Yeah, 5f minus 32 is equal to 9c. And to get rid of that 9 to make c to be alone, we would take it over the equal sign, and hence it's multiplying on the right. It would then divide on the left. So now we'd have 5 open bracket f minus 32 over 9 is equal to c. And that is how c becomes the subject of the formula.
So C is equal to 5 bracket F minus 32 over 9. All right. So we can, if you want, we can go and distribute this. We can leave it as that. Well done, Brandon. Well done. So I see somebody said Maya was cooking. Yes, she was. All right. Maya was cooking. Brandon was cooking as well, right? So the next one says, given that F is equal to 500 and where did I get 500 from? F is equal to 113. Calculate the value of C. So they said, let me finish this off. So F is equal to 113. They want us to find the value of C. So this F this here is equal to that. So all we got to do is just put in that 113 into that equation. So we'll have C is equal to 5 open bracket. Instead of F, you'll say 113 minus 32 all over 9. And C would be equal to, so let's work with the bracket. So 113 minus 32, that would give us minus 32, that would give us 81 times 5 divided by 9. Would give us, when we work all this out, we should get 45 as our answer. All right. So C is equal to 45. All right, C is equal to 45. All right, very good. So you have to have a flyer. Everybody has been cooking on the chat. Everybody has been cooking on the call. Let's proceed. So we now get started, right, folks? We got everybody on this chat, on this call, we got to get ones and twos, right? We're ones and twos. If we do bad, we'll get a 3. But the aim it for bare ones and bare twos. The fact that everybody's here, we get any ones and twos. So we enter some matrices. So I see Professor Daniel has his hand up. The man who has a farm, and on that farm, he has only aura. Go ahead, Professor Daniel.
Okay, sir. Okay, sir. So the question reads, given that matrix M is equal to 2, 1, 4, and 3, I is evaluate M inverse or the inverse of M. So firstly, there is a formula for the inverse of a function of a not a function of a matrix, and that formula is the inverse of the matrix is equal to 1 over the determinant times the adjoint matrix. Thank you. So let's take this piece by piece. So first, let's find the adjoint matrix C. So to find the adjoint matrix, what we do is we switch the 2 and the 3, the main diagonal.
So
And
let me
then
just write back that. So this would be 2, 1, 4,
Mhm.
3. Yeah.
We switch the places of the 2 and 3, which would be 3 and then 2. And then we write the inverse, which would be the negative or the positive of the 4 and the 1, which would be -1 and -4.
All right, so we flip the signs of these two, right? I don't like the word inverse. So we flip the signs of these two.
Okay.
Good. So -1 and -4. Good.
Okay. So now we have the inverse. We can put it into the formula. Now, once it's in the formula, we have one last part, and that is the determinant. So you're gonna put it in? Okay, good. So the determinant is equal to A times D subtract the C times B. So quickly, because A, B, and B, C might sound a little bit foreign, the first element, which is 2, is A. The second one, which is 1, is B. The third 4 is C. And 3 is D. It always is. It don't change. Don't change. So good, we could write this as, we could substitute into the equation and get 2 times 3. 2 times 3. Subtract 4 times 1, or 1 times 4. So good. We got a nice equation, all right? Very nice equation. So 2 times 3 is 6. So it would be 6 subtract. And then 4 times 1 is 4. Yeah, 4. 4 times 1 is 4. So 6 subtract 4. That would be 2. Right, sir? 2. Good, it's 2. So now we gotta take all the parts together and put it into the equation, right? So we rewrite it as 1 over 2, or half, as some people would say. 1 over 2 times the adjoint, which is 3, negative 1. Or the adjoint. 3, negative 1, negative 4, and 2. And then close out the bracket. Good. So now we multiply it in scalar multiplication. Now simply just put the 2 on each one because the numerator is 1. So it would be the same. So it would be half times 3 would be 3 over 2. We're doing it piece by piece, right? So now negative 1 times that would be negative 1 over 2. We got to do this thing piece by piece. Negative 4 times the half would be negative 4 over 2. And then lastly, 2 times the half would be 2 over 2. We got to do this thing piece by piece. We can't just skip steps. We're doing this one CXC paper. So good. 3 divided by 2. Now we could break this down further. Now equal, open matrix. Now 3 divided by 2, that is 1.5. Now our second element, which is negative 1 divided by 2, and that is negative 0.5. Now the third element, which is negative 4, 2 can go into that 2 times, it's just be negative 2. And now 2 over 2, really nice thing. 2 can go into 2 one time. So it'll be just 1. 1. Or 1. Good. Now close it up. Now we can't forget to put m inverse is equal to that. Right, sir? Right, m. Very good. Because CX gap see we answer. CX gap know what we put in, right? Good. Yes, and that is m inverse.
All right, excellent, Daniel. Excellent. Excellent. So as Daniel broke it down piece by piece, the formula is just 1 over the determinant multiplied by the adjoint. You find the determinant first, and then you find the adjoint, and then you just put them together, and that will give you the answer for the inverse. Absolutely easy if this comes on your paper. It's absolutely easy. These things go for a lot of marks, and I view it as very, very, very easy marks. I would pray day in, day night, day in, day out that this comes on your paper this year because it's very easy. All right. So and it goes for a lot of marks. So that is the inverse. The next one, so let me write it back. Show that the inverse times m is equal to I. So the inverse of m times m is equal to I. So Daniel, you want to finish it off? Go ahead.
Yes, sir. Yes. You can hear me, right?
Yeah.
Okay. So anytime you multiply the inverse of a matrix by itself, it is always equal to the identity matrix. But CXC, this question says show. No, CXC, I was like, put for proof things. So we need to break this thing down piece by piece. So we could rewrite the inverse. Rewrite the inverse. And now multiply it by the original matrix.
Which is 2, 1, 4, 3. 2, 1, 2, 1, 4, 3. Hold on, Daniel. Let me see if I got some space. All right. Hold on. Let me add in another page. All right, let me add in another page. Where are we?
Fancy, we got the pages.
All right. So let me bring this down so we have enough space to work. Yeah, Daniel, go ahead.
Yeah, sorry, yes, we get with page. So first of all, when you're multiplying two matrices together, you need to remember one thing. You always multiply by the row by the column. The row of the first matrix by the column of the next matrix. Now these two matrices have the same order, so we know we can multiply them. Both of them are 2 by 2 matrices. So how we multiply is we can open our matrix. Yes, you can open it. Now the first element in the first row of the first matrix, that's a lot of forces, is 1.5. So it will be 1.5 times the first element in the first column, which is 2. 1.5 times 2. And now plus the second element, which is negative 0.5, times the second element in the first column, which is 4. And now we have to close it off, to close the bracket off. Yes.
Close off already, you sure? Close
No,
it
no,
till-
no. The first one is with negative 0.5 times 4. Close that one off. That's finished.
Oh, this one dark
Yeah.
one.
Mhm.
All
Sorry.
right. Sorry, too
Sorry.
much arrow.
Next, right side before. Don't leave the 4 out, please.
Wait, now we'll close stuff here as in like this.
Yes, yes, yes.
Okay.
Thank you, thank you, thank you, thank you.
Right,
Thank
anyways,
you.
just want the thing is why you close off why you put this bracket here. You want to
Just
separate it with
separate.
signs, right?
Yeah.
You got this negative sign and this plus sign, so you want to separate them, right? Very good. Continue, Daniel.
Negative and positives don't mix in this world properly. So yes, let's do the second element because we see we still have another column. So we continue row multiplying by the same row. So we can do 1.5 times 1. You might want to push that a little bit over to the left because it won't fit. But yes, 1.5 times 1 plus negative 0.5 times 3. Good. We run out of columns now. So we can move on to the next row, which is negative 2 and 1. And we do back the exact same thing. So it will be negative 2 times 2 plus 1 times 4. And now we still have another column, so we move on to the last element. And it is negative 2 times 1 plus 1 times 3. Good. So we're going good so far. We're going good so far. Now we basically just do the operations out. So we can do it piece by piece, which would be now 1.5 times 2 would be 3. So it'd be 3 plus, and then negative 0.5 times 4 would be negative 2.5. We could put a bracket.
You sure?
When you have a positive and negative, the negative takes precedency, so you can just remove the positive.
So this one you work, right?
Yeah.
Try it back, do it back. Remember, it's like you got negative half times 4. It's like 4
Negative
divided by
0.5 times 4.
it's like you got half
Negative
times 4,
2. Negative
right?
2.
Good.
Don't be like me, people, right? Recheck your things. Make sure you're calculating the entire radians, right? Yes. So when we have something like this, 3 plus subtract 2, this is a sin. So anytime we have something like this, the negative takes precedency. So we can just move positive over. Just delete positive. Eraser it. Yes, yes, yes. Good.
So when Daniel says it takes precedence, I mean you got a plus and a minus, right? This is like these two signs are multiplying, and we know a positive times the negative will end up in a negative, right? So the two signs will cancel out and give you a negative. Yeah, Daniel, continue.
Good. So now this part finished, we could move on to the second part, which would be 1.5 times 1. Now to make sure I don't do anything wrong. Good. Now anytime you multiply something by 1, it's itself. So it would just be 1.5 plus Now to make sure I don't do something wrong, let me use my calculator. So it reads 0.5 times 3. That will be the half, which is negative 1.5. Now, you could remove the positive because we know it's going to be a negative. It's negative already, so you can remove positive. Good. And now we move on to the bottom left, which should be negative 2 times 2. So we know that 2 times 2 is 4, but when we have a negative and we multiply by a positive, the negative again takes precedency. Negative always takes precedency. So it'll be negative 4. We have negative 4 plus, and again, 4 times 1 would be itself, so it would just be 4. Negative 1 plus 4. Good. And now we move on to the other one, which is the bottom right, which is negative 2 times 1. Negative 2 times 1 would just be negative 2. So negative 2 plus, and then again, 3 times 1 would just be 3 again. And so now we have to simplify this thing back again. So 3 is, so good. 3 subtract 2 would be 1. Then the next one would be 1.5 subtract 1.5 would be 0. Negative 4 plus 4 would be 0. And then negative 2 plus 3, which you could write as 3 subtract 2, would be 1. And this is the identity matrix, which is basically the matrix way of writing 1. Yes, that is it. Bye-bye.
Very good, Daniel. And the marks cut off. This probably went for like I would say about 2 marks. 2 marks or 3. I would say 3 because you'll have to know what the identity matrix here. 2 or 3 marks, right? Nice and easy, just simple matrix multiplication. All right, well done, Daniel. All right, excellent. Well done, well done, well done, well done. Let me finish this off now. Let me finish off this one. Let me just add in the page and finish it off quickly. Where are we? Add page. So this one, the last one says, use the matrix method to solve for R, S, T, and U in the equation. We have the equation here. So let me write it back. 2, 1, 4, 3. And that multiplied by R, S, T, U. And that is equal to 2, 1, 4, negative 1. So I'll just use that and I'll drag it down. Let me drag it down to the bottom. Yeah, so I want to solve this equation so that I'll have the value for R, S, T, and U. So whenever you're solving any equation, all right, whenever you're solving any equation, well, matrix equation that is, basically taking this over the equal sign. You're carrying this over the equal sign. And many may say that this is multiplying, so we take it over the equal sign, it will divide, right? But when you take it over the equal sign, it will not divide. It will turn into the inverse of whatever it was on this side. And that is actually what we're doing when we actually doing it in algebra now. We take something over to become the inverse. But nevertheless, in this case, when we take this over the equal sign, when we take this matrix over the equal sign, it will become the inverse of what it was over here. So the fact that we already found the inverse, and that is the beauty about these kind of questions from CXC, you will have to use what you found before to answer probably one of the questions. So the fact that we already found the inverse, that will make our work way easier. So we found the inverse for 2, 1, 3, and 4. We found it to be this here. So I'll just copy this. And so I will have R, S, T, and U. And when I take this over, that will turn into the inverse multiplied by this. So I will paste that there, which is the inverse of this, multiplied by what we already have here, which is 2, 1, 4, and negative 1. And then when I work this out, the corresponding elements will give you the answer for R, S, T, and U. So I do row by column. I'll go through it quickly because we just did matrix multiplication. So row by column. So it will be 1.5 times 2 plus 0.5 times 4. And then I'll do the same 1.5 times 1 plus negative 0.5 times negative 1. Then I go second row, first column again. So negative 2 times 2 plus 1 times 4. Now, a key thing to note, if you're going correct, many times we tend to mix up, especially when dealing with matrix multiplication. One thing you want to be on the lookout for would be these two here should be the same. All right, for all. Just like we have those two there, we'll also have negative 2 times 1 plus 1 times negative 1. So all these here should be the same. That is one thing you want to be on the lookout for when you're doing matrix multiplication. Once they are the same, you know, you're good. You're going good. And then we work this out. Do some simple maths using our calculator. So 1.5 times 2, 1.5 times 2, I think that will give me 3. Plus 0.5 times 4, that will give me 2. Then work with 1.5 times 1, that will give me 1.5. Negative 0.5 times 1, that would give me a positive 0.5. And negative 2 times 2, that would give me a negative 4 plus 1 times 4 would give me 4. And negative 2 times 1 would give me a negative 2. And positive 1 times negative 1, that would give me a negative 1. So I have plus negative 1. And then I do the final thing, which will be 3 and 2 is 5. 1.5 plus 0.5 would give me 2. Negative 4 plus 4, that would give me 0. And negative 1 plus negative 2, this will cancel out and be a minus. So negative 1 minus negative 2 minus 1, that would give me a negative 3. So I have RSTU is equal to that. And to finalize, to get my answer, collect all the marks from CSEC, I'll equate the corresponding matrix, a corresponding element. So I'll have R is equal to the 5. Then I'll have S is equal to the 2. And then I'll have T is equal to 0. And I have U is equal to negative 3. I got all 3 of the marks there. All right. Somebody says, so what? Okay, good. So what I'm learning is to skip all the matrix question. Now, don't do that. Don't do that. Don't do that at all. Matrices are very easy. All you need to do, I'm telling you this, all you need to do is practice. Matrices are very, very, very easy. I don't say things are very easy if they are not. All right. Matrices are very easy. Go and practice. All right. Don't give away these kind of marks. You can give away marks in the measurement. I mean, you should not be giving away any marks, right? But you can give away marks in the measurement because those things can be a little tight. I won't lie. The measurement questions can come a little tight depending on, how the examiner or the person setting it was feeling. Right? It can be a little tight. You can afford that, but matrices at all, don't leave anything on the plate. Take all of the marks. So learn matrix. They got 60 days to learn. It is very easy. It's just rote knowledge. You just gotta learn the steps, and that is it. No big fancy application. So all of a little bit marks. No, these things tend to go for a lot of marks, right? 3 marks and so on. So that is it for matrices. I think we touched almost everything as it relates to matrix. We touched we touched finding the inverse. We touched solving equations involving matrices. We touched on scalar multiplication. Another thing I want us to touch on, let's say if they say a matrix, if they say a matrix is singular, If the same matrix is singular, let me see if anybody in the chat knows what that means. If a matrix is singular, what does that mean? All right. All right, so sorry, but I was getting a call. Yeah, so I see everybody saying when they say matrix is singular, that means the determinant is equal to 0, right? The determinant of a single matrix is equal to 0. All right, when they say it's singular. So my tablet is dying.
Plug it in, plug it in, plug it in.
So hold on. So let's give me a second, folks. So my computer is linked to my phone, so because my phone rang, everything is back now. Yeah. So let me see which answer is wrong. Did I make a mistake? Yeah, so let me see. R is equal to 1. Let me see. R. So oh, so this here is a negative. Yeah, yeah. So this here is a negative 0. So this will be a negative 0.5 times that. So this will be a negative 2. Hence, this plus and this minus here will turn into a minus. So R is equal to 1. All right. R is equal to 1. Yeah. So, yeah. So you want to be careful with that, right? Signs. The signs are very important. All right. The signs are very important. And that is how, you can lose marks simply by making a mistakes with the signs. The negatives, they can cause you, right? So be careful with that. How did I miss that? So what time you finishing? We're going up until 2 in the morning. Everybody just stay. We got a secret at the end of this video. A secret. I'll share a secret at the end of this video. Those of you that make it till the end, I'll share a secret as it relates to something very important. So those that stay till the end, you will be able to hear that secret. All right. So that is that. So we still. So we want to tackle this one here. We still at matrix. All right. I see. See my good friend Amber. Amber, go ahead. Read it and then answer it.
Okay, right, everybody. So to calculate the matrix product, you would have to multiply row by column. So you open your brackets. 5 times 2.
Hold on, Amber. Give me 1 second. I'm trying to
Mm-hmm.
oh yeah. Yeah, go ahead, Amber.
I'm sorry. Yeah, so 5 times 2.
Let me start it off. So you have the matrix.
Okay.
Hold on, Amber. So you have the matrix 5, 4, negative 3, 2, 2, 1, negative 4, 0, 3, 6. Before we multiply, Amber, there's an important thing that we have to do that will
Check the
guide us.
compatibility.
Yes. Other than
Okay, so
compatibility. Yeah. Yeah, go ahead.
So the dimensions of the first matrix is 2 by 2. You go row by column to identify the dimensions. So you have 2 rows, you have 2 columns. And for the second matrix, it's 2 by 3. You have 2 rows and 3 columns. Okay, so to check to see if these two matrices are compatible, you would look at the two inner numbers, which would be the amount of rows for both. Sorry, no, the column to row. Yeah.
Row by column. So read columns, eh?
Row. Yeah, the column. Sorry. Anyways, you can see that it's compatible, and you can also see something else there, that the answer you're gonna get is gonna be a 2 by 3 matrix. So yeah.
Excellent.
Yes, so now you can start multiplying. So it would be 5 times 2 plus 4 times 0. So the first number to the corresponding number on the other side, so it's row by column. Now 5 times 1, 4 times 3, plus 4 times 3. And then 5 times negative 4. Sorry, 5 times 4.
Negative 4.
Yeah, 5 times negative 4 plus 4 times 6. And now for the second row in your first matrix to multiply the second matrix. Negative 3 times 2. So negative 3 times 2 plus negative 2 times 0. Negative 3 times 1 plus negative 2 times 3. And the last, negative 3 times 4 plus negative 2 times 6. Negative 3 times 4.
Negative 4 plus.
Negative 2 times positive 6.
All right, pause here, Amber. So I want everybody look once again. We see all of these here are the same, right? All of these are the same. If they are not the same, check back. All right? Yes, Amber, finish it.
Yeah. So you just multiply. That's how I work it. I don't know if there's any other way. Not any. So 5 times 2 is equal to 10. 5 times 2 is equal to 10. Plus anything multiplied by 0, we should know is 0. 5 times 1, 5. Working across, by the way. And 4 times 3 is 12. 5 times negative 4 is negative 20. And 4 times 6, 24. I'm going to write the second row now. So negative 3 times 2 is negative 6. And again, anything multiplied by 0 is 0. So negative 2 times 0, 0. Next thing is negative 3 times 1. That's going to be negative 3 plus Negative 2 times 3 is negative 6. And the next string, negative 12. Negative 3 times 4 is negative 12.
Negative 3 times negative 4. Over the sign.
Times negative 4. Well, it's going to be positive 12 because the negative and the negative cancels. So, what? Oh, yeah. Negative 2 times 4 is negative 6. What? Negative 2 times 6 is negative 2.
Plus negative 12. What time is it? 9:30? What time will I sleep? Anyways,
Sir,
finish it
I
off.
had a very long day. Anyways. So 10 plus 0, 10. 5 plus 12, 17. Negative 20 plus 24 is going to be 4. And then second row, negative 6 plus 0, negative 6. So for this one, there's a positive and a negative. So in this case, the negative sign is going to govern. So negative 6 plus negative 3 plus negative 6 is negative 9.
So it'll be negative 9.
And for the last thing, it's going to be 12 plus negative 12. You're going to minus, again, positive and a negative, you minus. You're going to get 0. And that's your answer. Can I just justify this one time go? So to state why the two matrices in this question is comfortable for multiplication.
Conformable.
Huh? Conformable. I feel allergic.
This number, you're going good. Excellent. Cook. Finish off. You're cooking. No
No, I
worries.
did not cook. But yeah. So the reason that these two matrices are compatible is by their dimensions, which we explained already. Do I like work it out? I've never done this.
This is state, so you just got to state, right? So you'll see.
Okay, so you just write up back the dimensions and
So
you're
you'll
good to
see the
go.
number, row by column, the number of columns. You see the number of columns in the first matrix is equal to the number rows and columns of rows in the second, right? That is how we can state that they are conformable or compatible for multiplication by their order. Earlier, we saw that the order was a 2 by 2 and a 2 by 3. So the fact that these two inner numbers are the same, they are compatible. And this here would be the rows. And this here would be the column, and this would be the rows. So we just put that in a statement. All right, excellent, Amber.
Okay, that's that. Thank you. Please do not bully me in the comment section like what y'all did last live.
Nobody's bullying you. Everybody's saying you cooked. All right. Did she cook? Yes, everybody's cooking. All right. So that is that. How long have we been live? Anybody here since the start? How many persons are here since the start? Remember at the end we dropping some secrets, right? Dropping some secrets like the guy from CIA on TikTok. All right, so we won't find the inverse. All right, let me do it quickly, just in case anybody. We already did the inverse, so we know the formula to find inverse of a matrix is 1 over the determinant times the adjoint. And as Daniel said, we take it piece by piece. So we find the adjoint first. So the adjoint of this would be, we switch these two. So this will become negative 2 and 5. And then we flip the signs of these two. This will become negative 4. And this will become a positive 3. And that is the adjoint. And then next we find the determinant. Determinant is AD minus BC. So this is A, this is B, this is C, this is D. So this would be A, which is 5 times -2, minus B, which is 4 times -3. And this would be 5 times -2 is -10, minus 4 times 3 would be -12. And these two negatives will turn into a positive. So this would be -10 plus 12. That'll be a +2. So the determinant is equal to a +2. So hence the inverse would be 1 over 2 multiplied by the adjoint, which is -2, -4, 3, 5. And then we just put everything over 2. All right, -2 over 2, -4 over 2, 3 over 2, and 5 over 2. And then this will simply give us -1, -2, 1.5, and 2.5 as our answer. And how many marks is well? For 2 marks, nice and easy. All right. Let me see how many portions here since the beginning. Tell me now, tell me now. Me. Yes. All right. So let's proceed. All right, who dropped this one? Who would like to tackle this one? You sure?
Yes, sir. No, when it comes to explaining, I'm very bad at it because I've studied too much.
All right, go ahead, read the question then answer.
The diagram below, not drawn to scale, shows a circle with the center O. The points A, B, C, and D are on the circumference of the circle. E, F, and E, D, G are tangent to the circle at A and D respectively. AOD equals 114 and CDG equals 18. So calculate the given reasons for each step of your answer. So first we have to find for ACD. So this is very simple theorem. Well, theorem 1 states the angle at the center is twice the angle at the circumference. So
What's that theorem one? There's no particular order in the theorems. I just say, a theorem.
Okay, well, the theorem states angle at the center is twice the angle at the circumference. So ACD would just be 114 divided by 2, which is 57.
All right, ACD, where is that? ACD would be right here. So one quick thing. So ACD, and if you look at a key tip for everybody, a key thing when you're dealing with circle theorem, right? It may be hard to identify which theorem to use. But I did a video on TikTok and I gave some tips, and these tips are valuable. So one of the tips that I said was that, you label your angles and you write it down, right? So since we are given ACD, let's look at another angle that we are given. We are given AOD. And one of the key thing with circle theorem is that these two end numbers, they kind of indicate that you can use a lot of theorems, especially the one that deals with the angle in the center and the one that deals with angle in the same segment. All right. So we have one angle in the center and one angle at the circumference. And that's how we identify we can use a theorem by labeling it and looking at the two end letters. As long as they are the same, our mind should immediately go on either it's theorem with the angles in the same segment or the angle at the circumference is twice the angle at the circumference. So Roquan said was correct. So we see it's 114 divided by 2, which is equal to once we got Roquan?
57. 57 degrees.
And the reason would be?
Because the angle at the circumference is angle at the center is twice the angle at the circumference. Yes.
All right, the angle at the center is twice the angle at the circumference. All right, good. So let me just put in that angle. So we found this here to be, and that is the next tip that I said, you put in the angles that you know. So this is 57. Next one, AED.
The AED, so that would be important there. So in order to find this, you have to use a theorem that states the angle between two tangents and the center add up to 180. So since they add up to 180, we just subtract 114 from 180 and we'll get the AED,
Which
which should
angle?
give us 6.
Repeat.
We give
Repeat the theorem.
angle between two tangents and the central angle add up to 180.
The angle between
Two tangents
add up to 180.
and the central angle.
All right, theorem. This theorem, right? I'm not sure you heard of that theorem, but this here we see a tangent here, and we see the radius, a radius being formed here, and there's a theorem that says the angle between the tangent and the radius is perpendicular, meaning it's 90 degrees. So this angle here would be 90 degrees, right? And the same thing goes for here. We have another radii, another radius. So this here is 90 degrees as well. So we have 90 here, we have 90 here, and we have 114 here. And if we look at this here, we see quadrilateral is formed, a four-sided shape. All right, and that is another one of the tips that I give, which would be to always be on the lookout for four-sided shapes or quadrilaterals, and always be on the lookout for triangles. So the fact that we have a quadrilateral, we know the sum of the angles in a quadrilateral would be 360 degrees. 360 minus
90 plus 90 plus 114
plus 90,
114
plus 90 plus 90. So be 360 minus, what we got here, Rowan?
Forget exactly that. And I don't have no calculator on me, but the final answer would give us 66.
294. So 66.
Yes, sir. AED equals 66 degrees.
So 66 would be the answer there, right?
Yes, sir.
So this here, the reason would be the
cyclic quadrilaterals add up to 360.
No. The reason would be the theorem. The theorem as it relates to the angle between the radius and the tangent, right? So the angle between the radius and point of tangency is 90 degrees, right? Or we can say perpendicular. And also there's another reason we said the sum of angles, sum of interior angles in a quadrilateral is 360 degrees. And that would be those would be our reasons. So some things we want to be on the lookout for would be quadrilaterals and the triangles, right? We didn't have to use triangles here. Let me see if we got any more. So we got we got OAC. Let me see. OAC. OAC.
There's a little piece there.
Yeah, let me hear you do real one. OAC.
Isn't that the little small piece, the little tiny piece?
Yeah, OAC. Let me hear.
Okay, sir. So, yes, sir. So we know that, well, where is it? It's a isosceles triangle. I mean,
Oh, you know, it's an
isosceles
isosceles
triangle
triangle.
because the was the radii yeah, with it was
Wait, OAC, this little piece here, right? You're talking about this little piece,
yes,
right?
sir.
This little piece is OAC, OAC. Yeah, isosceles. Good. Yeah, two radii, bops, bops. We got the two radii here. So we know we got two radii, and the fact that and this is the next thing, next tip that I give, always be on the lookout for isosceles triangles. Always be on the lookout for them. From the time that you see two radii, you know you have to involve isosceles triangles. Sorry, this really distracted me. Please go over. Which children distract you? All you got to do is blank out the comments. Why are you reading? Why are you looking at the comments? Turn off the comments, as in exit out and focus on the video. Come on, come on. So we know these two angles here would be equal. We know those two angles would be equal. We know those two angles would be equal, so we can say 180 minus 180 minus 114. That would give me 180 minus 114. That would give me 66. So 66 divided by 2 would give me 33.
Yes, sir.
So I paused just now because I was thinking, right? I was thinking how to get this answer because we didn't work it as yet. All right. And sometimes these questions can become tricky and difficult like that. So here's the thing. We know both sides here would be equal to 33. We know this angle here would be 33. And this entire thing here would be 33 as well. So we know this is on. Let me zoom up now. So we know this color is a pink is 33. And we know color in blue is 90. So to get this little piece here, all we got to do here to be 90 minus 33. Can't be 90 minus 33. Let me see.
You're already trying to find exact. Let me assist you.
Oh, yeah, let me hear.
Yes, sir. So we know that well, the theorem, the angle between a tangent and a chord equals to the angle in the opposite segment of the circle. So you see what is okay, I'm not good with this part, but with the angle 18 degrees would go right on. Well, I don't know how to see it, but
All right, see
on
this
the
angle formed, and then we have a triangle formed here. So we know here is also equal to 18, you see?
so okay, good. So we found 18 and then the 33, which we subtract 33 from 18, which would give us OAC. Yes, OAC.
Yeah, excellent, right? So 33 subtract 18. That will give us 15, right?
Yes, sir.
So this one was trouble, right? So we use the same theorem as relates to the isosceles triangle. So we know the isosceles triangle, this big piece here would give us third. This big piece would give us 33. And we know this little piece is 18. So to find this remaining piece, it's simply 33 minus 15. All right. And that is how sometimes circle theorem can have you like that, right? Circle theorem questions, they can be very straightforward and easy, but sometimes, you gotta do some amount of work. Once again, be on the lookout for isosceles triangles, be on the lookout for quadrilaterals, be on the lookout for cyclic quadrilateral. We actually have a cyclic quadrilateral. For some reason, we didn't use it though. Actually, ABC. ABC, that is the last one I want us to find. ABC. ABC, which is this angle here.
Yes, sir.
Yeah.
So yeah, to find ABC, we'll have to use back the same theorem we just used, which is the angle between a tangent and a chord equals to the opposite segment. So we see 57 would also be equal to
Pause real quick.
the trend.
Pause.
Yes, sir. Yes, sir.
So we see a cyclic quadrilateral there, right? Always be on the
Yes, sir.
lookout for cyclic quadrilaterals. Is one of the things. Always be on the lookout. From the time you see a cyclic quadrilateral, you'll have to use it. Always be on the lookout for that. So probably that would be easier. What do you think?
Yes, sir.
So yeah, let me hear.
So we would since the theorem states equal, we put the 57 right above where the third chainsaw is. So that would be 57 also.
All right, nah. So the next thing to look out, we have a triangle being formed here. So since that's a triangle, we know this angle here would be 180 minus 57 plus 18. That would be 180 minus 57 plus 18.
75.
180 minus 57 plus
Which would give us 105, sir.
105. So if this angle here is 105, if this angle here is 105, remember I said from the time you see a cyclic quadrilateral, you'll have to use it. So if that angle is
Yes, sir.
105, I know this angle here would be the opposite angles in a cyclic quadrilateral would be supplementary, meaning they add up to 180 degrees. So folks, this here would be 180
75.
minus 105, which would give us
75. Well,
75.
I did it a different way though, sir.
All right. Sure, it's correct, right?
Yep, it is. I know about this way, but yeah, I just did it.
Yeah, the thing is with these theorems, you can do different theorems, right? Depends on which angle you put in and so forth. So yeah, but let me just give you some tips again. Somebody says, sorry, that's 90. No, it wouldn't be 90, right? It wouldn't be 90 at all. I know some people think you assume that this here is the diameter, right? Some people assume that this here is the diameter, but no, it's not the diameter, right? The diameter, they said O is the center. If this line had drawn straight through O and go to the end here, then that would be, then we can use that theorem that you're talking about. But no, it didn't pass through the center, right? So be careful, don't assume. Make sure it's. So yeah, folks, let me just give you some tips. So always be on the lookout for cyclic quadrilateral. From the time you see that, you'll have to use it in the theorem. Be on the lookout for isosceles triangles or triangles in general. Be on the lookout for quadrilaterals. The sum of interior angles would be 360. And yeah, you're good to go there. All right. And just remember your theorems. Don't cram them. Don't cram them, learn them, right? Don't cram them. So that is that. This is probably this is probably a tight one for circle theorem. But yeah, not too difficult though. A little tight, but not too difficult. So I've been talking a lot. Let me hand y'all over to somebody. Christian, go ahead. Read the question and answer, right?
Okay, sir. Two functions f and g are defined as f of x is equal to x squared subtract 1 and g of x is equal to 3x plus 2. Find g, which is equal to negative 6.
G of negative 6.
G of negative 6. All right, sir. So we put back the function g of x is equal to 3x plus 2. And now for the negative 6, we have to substitute it where x is. So it will be 3 bracket negative 6. No, sir. Yes. Plus 2, which is equal to a positive and a negative is a negative. 3 times 6 is 18 plus 2, which is equal to negative 16.
Right, G of negative 6 is equal to all right, 1 mark, right? So yesterday I think I stated functions in a video that functions. That was easy, right? Somebody's asked what time you going to bed. When have we done, right? Remember CXE, the mock exam is in 9 days. So yeah, it's war, man. Mine no matter. So excellent, Christian. Excellent, excellent. Who else we got on this chat? Some people, where everybody else gone? Ditch and ditch. Oh no, my are there. So I didn't hear from. I heard from Brandon already for the night. Gracias, go ahead. Thank you, Christian. Well done.
Okay, so this question states to find the inverse of the function to find g inverse of x. So g of x is equal to 3x plus 2. Now to find the inverse of the function, first we replace the gx with y. So then we'll have y is equal to 3x plus 2. Then we replace all the x with y and the y with x. So then we'll have x is equal to 3y plus 2. Now we make y the sum to the formula. So first, we will move the 2 over the equal sign. So we'll have x minus 2 is equal to 3y. Then we divide everything by 3 to make y the subject. So we have x minus 2 over 3 is equal to y. So g inverse of x is equal to x minus 2 over 3.
All right. Thank you. Yes. Well done. Excellent. Excellent. 2 marks. Nice and easy. 2 marks. Functions. I love functions as a student going to school, and I want everybody to love functions as well. All right. So when we got the normal functions like this, it's just a simple matter of substitution. When we got inverse functions, we know we just follow the steps. Replace with y, interchange the x and y, make y the subject. 3 simple steps. All right. What else we got here? Who else we got on here, boy? All right, let me tackle this one. So show that if g of x is equal to this, you have to show, and this is going for 3 marks. So the thing about these show questions, when you see a question mark show or prove, that means, you're working towards that answer. You're doing whatever you want to do, and you're working towards this answer here. So basically, all you got to do here is find FG of X, and, you should get this answer. That is all you're working towards, all right? Show and prove. Yeah, so from the time if your answer is equal to this, you could leave the exam room knowing that you walk away with 3 marks. That's the beauty about these show questions. I loved show questions as a child, right? Because you know your answer is correct. So let me just write back the functions. X squared minus 1. So f of x is equal to x squared minus 1, and g of x is equal to 3x plus 2, 3x plus 2. So you want to find fg of x. That means you're taking a function g. You're taking a function g and you're putting it inside of x. You're taking a function g and you're putting it inside of x. All right. So this would be fg of x would be equal to, so we're taking this function here and we're putting it inside of this function. And how do we put it? By wherever we see x, we replace it and put that function. So instead of x squared, we'll have 3x plus 2 squared minus 1. Why did somebody say the determinant is equal to 0? I think that person needs to fast forward the video, right? You gotta fast forward the video. Anyways, glad that you probably went back to thing, but yeah, let's continue. So I think this is the part where the marks you really get your marks. Many students, as big as they be, as brilliant, they tend to forget how to work out this piece. So this is actually equal to a mistake that students would make. They would go and say, all right, by 3x plus 2 squared, they would go and say 3x squared plus 2 2's 4, and they're gonna lose all the marks. So no, you have to set this up like this. This will be 3x plus 2 multiplied by 3x plus 2. All right? And then minus 1. So we work this out. Many people struggle with this, but an easy way to do it, you take the first term and you multiply by everything in that bracket. So this will be 3x multiplied by 3x plus 2. And then we take the second term, which is 2x, which is 2. And you multiply it by 3x plus 2. And you put back the minus 1. We trouble in the minus 1 for now. So we distribute and work. Actually, no. Hold on. All right, let's distribute and work. For some reason, I think we gotta do some fancy thing. So, yeah, let's go. So this will be 3x plus 2 is 9x squared. 3x times 2 will be plus 6x. 2 times that will give us plus 6x. 2 times 2 will give us plus 4 minus 1. Hence, this will be 9x squared plus 12x plus 3. And I now I see where we going. So we want our answer to look like this, right? So what I'll do, I see they have a 3 out in front here, and I see I have a quadratic. So what I will do, I will factor out a 3 from everything here. So I'll have 3. I'll factor out 3 from everything here because I see 3 is a common factor among all of these. So this is why this thing is worth 3 marks. This is the part where many people say, all right, but we can get this here, let me move on. But we see 3 is inside of all of these things, so I factor out that 3, and I'll have 3x squared plus 4x plus 1. And then I see we have a quadratic here, and when I work out this quadratic, I should get this piece here. All right? So ABC, so I see A is equal to 3, B is equal to 4, and C is equal to 1. So AC would be 3 times 1, which would be 3. And 3 plus 1 would be 4. So nice and easy. So I substitute that 3 plus 1 here. So this would be 3 open bracket. So let me put this in 3 open bracket. 3x. So here what I'll do, I'll factor out this piece at the side here. So 3x squared plus 4x plus 1 to make it easy. And then when I'm done, I'll put that here. So this would be 3x squared plus 3x plus x plus 1. And then we put them in two brackets. So we factor out the 3 fours from the fours bracket, 3x from the fours bracket. So we'll have 3x, we'll have x plus 1. So we don't see that we got that one there. And then in the other bracket, we'll have plus 1. Then we'll have x plus 1. So we'll then bring down, we have 3x plus 1 in a bracket, and then x plus 1 in a bracket when we finish factorizing that. And then now I can bring this here and put this here. So I'll have, when I finish factorizing that, I'll have 3x plus 1 and x plus 1. And that's I end up with this here. And this one went for 3 marks, right? So this one was a little tight. So you see when a question is worth 3 marks, probably there's a short way. Probably I did something extra, maybe, or maybe not. But yeah, when you see things are worth 3 marks, know that you got to work for it, right? So in this case, we had to do the concept of composite functions. And then we had to use the knowledge of the AC method, right? Factorization. And then we just put all together at the end. Anybody? So this is all a little tight. This is probably the hardest function question I've ever come across. But it's easy. It's easy, but it's different. All right. So if you see this here in the exam, you know what you have to do. How was this one, folks? Tight or it was easy? How was one looking? Tight, easy, beat you up. Hence, solve the equation FG is equal to 0. So all we got to do is equate. The thing is, this question went for 1 mark. Even if it didn't get your answer, even if it didn't show this, you can still work this out. All you got to do is equate this here to 0 and solve. So all we got to do is equate that. So all we got to do is equate 3, open bracket, 3x plus 1 and x plus 1, and we equate that to 0. All right, we solve this like how we solve a normal quadratic equation. So we know how we take over this 3 is multiplying everything. We take it over to, it will become 3 multiply 3 divided by 0, 0 divided by 3, it's be same 0. So we'll end up with 3x plus 1, x plus 1 is equal to 0. All right. So then we just equate the two brackets to 0. So we have 3x plus 1 is equal to 0 and x plus 1 is equal to 0. On this one side, we'll have x is equal to -1. And on this one side, we'll have 3x is equal to, take over that positive one, it becomes -1. And x is equal to -1 over 3. And that will be our two answers there. All right. And that is that. Let's push forward. Who want to tackle this one? Komisha. So we have a new person in the chat, Komisha. Go ahead, Komisha.
A rectangle PQRS has a diagonal PR, where P is the point -3 and 10, and R is the point 4 and -4. Calculate the length of the line PR. So firstly, we got to find the length of line. To find the length of line, it's the square root of x2 minus x1 all square plus y2 minus y1 all square.
So this is one of the formulas you got to remember. Right? I don't think this formula is given. So the length of line, distance between 2 points, and so on. This is the same formula as distance between 2 points, right? So you got to remember this. Yes, Commissioner.
Now we plug in the coordinates into the formula. So x2 is 4.
Let's label this source. This is x, this is y, this is x, this is y. Which one is x1 and y? Which one is x1?
X1 is negative 3.
And this is y1, and this is x2, y2. Yes, plug in now.
So x2 is 4. X1 is negative 3, close bracket.
So minus negative 3, close bracket, squared.
Plus y2, which is 4, negative 4.
Negative 4.
And y1, which is 10.
Minus 10.
Minus 10 squared. 4 subtract negative 3 will give us negative 7. No, a positive 7, my bad. Negative, negative is a positive.
So this would be 4 plus 3 is 7 squared.
Plus negative 14. Negative 4 minus 10 is negative 14. And 7 squared is equal to 49. Plus, when we square a negative number, it always becomes a positive. So it will become positive 196. And when we add that up, we get 245.
What you got?
245.
245.
And when we square that, we get
Square.
15.7 units. After we round it up, it was actually 15.65. And when the number is greater than 5, we round up by 1. So we get 15.7.
All right. So normally you round off to 3 significant figures, right? Very good. So two marks, 2 nice and easy marks. Nice and easy marks. Nice and easy marks. No, yeah, I gotta stay till the end and then we'll drop the secret. Maybe we'll take off this video because of the secret that we'll drop. Maybe it's a very serious secret. All right, next one. So well done, Kamisha. Well done, well done, well done.
Sir, I think you skipped a part.
Oh, we skip a part? Oh, yeah. Let me zoom out.
So now we have to determine the equation of the line PR. As we all know, to find the equation of the line is equal to y equal mx plus c. Firstly, we got to find the gradient. So gradient equal to the change in y over the change in x.
All right, so we can say y2 minus y1 over x2 minus x1.
So y2 equal to negative 4 minus y1, which is 10. And x2 is 4 minus x1, negative 3.
Repeat. Negative.
No, positive 4 minus
Minus.
negative 3.
All right, good.
And when we work out at the top, negative 4 minus 10, we get negative 14. And 4 minus negative 3 gives us a positive 7, which will give us negative 2.
So the gradient is negative 2. Good.
So now we can substitute that into the formula. So it will be y equal to negative 2x plus c. And I use the coordinates negative 3 and 10, which is p. So it will be 10 equal -2, open bracket, -3, plus C. When we work out -2 times -3, we get a +6 plus C. And if we take over the 6, we would get 10 minus 6, which will give us 4, and C will be equal to 4.
So we got C and we got M, two main ingredients for the equation of the straight line, the two main ingredients, C and M, right? Finish it off, Amisha.
So now we will have y equal -2x plus 4.
Hold on, Kamisha, let me just do this thing. Yeah. So y equal
-2x
Mhm.
plus 4.
Good. And that is there for 3 marks. As you can see, this is probably the easiest 3 marks you'll ever get. The key thing when you're dealing with every time I see something. All right, so the easiest thing when you're dealing with equation of the straight line, well, the key thing is to find the value of the gradient and the y-intercept. Those are the two key things you need to find. And all you need 1 point on the line and either the gradient or the y-intercept. Any one, and then you substitute and you can find the other. All right? All right. Now let me just block a few persons. So I would advise folks in the chat. People already know that, they on a certain level, so they want to drag you with them on the grade 5, right? So don't be too distracted. All right. So excellent, Komisha. So we did functions. What time is it? 10:16. How we looking? How we looking, chat? How we looking? What time y'all want us to finish? We learning a lot? We still learning or retired? Wide awake. All right, love to see it.
We are wide awake and still ready to learn more.
Excellent. So we'll
It's
press
past my
on.
bedtime.
We'll press on. All right, we'll press on. So let me tackle these here. So these here are some functions. When I can remember when this came in the exam, a lot of persons came out crying, saying, "Oh gosh, you never see functions come like this. Oh gosh," and yada yada yada. So let me work this so that if this comes in your year, you won't end up like those persons. So it says we have two functions, f and g are defined as follows. F of x is equal to 3x plus 1. G of x is equal to x squared. Find in its simplest form an expression for f of x minus 2. All right. By the way, I'm learning about this YouTube. Yeah, how do you? Yeah, never mind. So let's go f of x minus 2. So we write back the function f of x is equal to 3x plus 1. So the thing is, we want to find f of x minus 2. Here's the thing. Just like if we have f of 2, and whatever is in this bracket, we replace it and we replace x with 2. In the same way, the same thing that is in this bracket, that is what we replace in x with. So instead of 3 times x, we'll have 3 times x minus 2 because that is what is in the bracket. Whatever is in the bracket, that is what we're substituting into the function. And then we put back the plus 1. And then this will be multiply 3 times x is 3x. 3 times -2 would be -6. And then plus 1. And that would be 3x. -6 plus 1 would give us a negative 5. All right, so f of x minus 2 is 3x minus 5. Somebody say they're hungry. No, we didn't do this one already. I would remember. We do something like this already, yeah. So the next one now, this is the next one that had students crying the year of the exam. 3x plus 2 in the bracket plus x. So we have the function g of x, which is equal to x squared. Now here's the thing, and we want to find g of 3x plus 2, all right, plus 10. You want to find what that is equal to. So the thing is, whatever is in the bracket, that is what we are substituting inside the function, not what is outside the bracket. What is outside the bracket, we'll put it inside the function, but we're not substituting that for x. So this here would be, instead of x squared, we'll replace x squared with whatever is in the bracket. That is what we're doing. So this would be 3x plus 2 squared. And then is when now we can put in this plus 10. So for x, we are substituting whatever is in the bracket. Whatever is outside the bracket, we put it when we don't do our substitution. The year when this question came, many students, what they did, they put 3x plus 2 plus 10, and then they square it. All right, and that was absolutely wrong. So this here will be, we work this out, this went for 2 marks. So this will be 3x plus 2 multiplied by 3x plus 2, and then we add the 10. So we take the first term, this will be 3x multiplied by 3x plus 2. I put the second term, which is plus 2, multiplied by 3x plus 2. And then we add on the plus 10. We distribute. So 3x times 3x is 9x squared. 3x times 2 would be plus 6x. And 2 times 3x would be plus 6x. 2 times 2 would be plus 4. 4 plus 10. And we work this out. This will give us 9x squared. And we add 6 and 6. Now the plus 12x. And 10 plus 14 is 10 plus 4 is 14. Feels like I did something wrong. Did I do anything wrong? I guess not. Forgive me your brain for this exam. All right. Yeah. So how you can get my brain? Let me tell you, when I wrote CXC maths, the mock exam, I got 27%, right? 27%, which is like approximately 35 out of 160 or 37 out of 160. And then I took that 27% and I went home, felt very sad, and allowed the sadness to push me to pick up the maths textbook. And I worked lots of exercise. I picked up the past paper book. I went and I bought a past paper book. And I worked day in, day out, day in, day out, day in, day out. I took about 3 days to realize that maths is not as hard as people make it out to be. And those 3 serious and intense days moved me from getting 27% to getting a grade 1. All right. So you don't need any big fancy brain. All right. All you need to do is be serious. And you got 66 days to get serious. Not anything big and fancy. This is coming from somebody that got 27% in a mock exam. All right. So that is that. Somebody said amazed I got a chance, but the thing is, as I said, I went home and I practiced, right? I practiced day in, day out. I did not scroll on TikTok for half day, right? I practiced. So I think we worked enough sort of theorem. You worked enough matrices. Did enough factorization. Let's end off the night with this one. This one here is a tight one. I can tell you, folks, this is the last question we work, and I'll tell you now up front, this one here, it's a little tight. It's a little tight, but you can get it with practice. This here a little tight. Right? This here a little tight. So you brace yourself. Brace yourself for this one. All right? So let's go. There's a young man here that says he want to work it. I'll give him that chances. I'm talking a lot. Is he still here?
Beautiful, beautiful, beautiful. Beautiful, yes.
So we'll end off with Danielle. And then I'll leave the secret. I'll leave the secret for the loyal persons who are here from the beginning. Anybody here from the beginning? Let me see. Anybody here since 8 o'clock?
Me,
Yes, us. Us.
I know
Anyway.
everybody
us.
here is here. Anybody from the chat since 8 o'clock?
Me open this chat.
All right. So I see somebody with the number one thing. That means they are the number one commenter. All right. So I'm sure these persons who are here since the beginning, I can guarantee you have that. It's not easy to stay on a life so long. That means you have that drive, right? You have the will to pass the maths. Now you have to turn that will into you actually doing practice. The only way you'll pass maths is by practicing, right? So after this video, take everything that you learn and go and practice. So, Mr. Ora,
What
over to
is
you.
this?
By
Oh,
the way,
hmm?
somebody in the chat said, anyways, I'll say it at the end. I'll say it at the end. Yeah, Daniel, go over to you. Read the question and take it from here.
We gotta finish this thing so we can hear the secret. Yes. B. In figure below, not drawn to scale. OE, EF, and MF are straight lines. The point H is such that EF is equal to 3 EH, and the point G is such that MF is equal to 5 MG. M is the midpoint of OE. The vector OM equals to V, and the vector EH is equal to U. Okay. Step number 1, don't get a heart attack. Step number 2, let me look at the question now. I. Write in terms of U and or V an expression for the vector HF. So first of all, what I like to think is that vectors is basically like mapping, and you're just trying to find the distance to some country or something. So you can imagine the capitalized letters as countries, like O, I don't know what country would be O, start with O. If anybody could think of a country start with O, yeah. So all the capitalized letters are countries you could think of it as. And the common letters like the V and the U are the distances. Now in vectors, we don't really use the numbers. So we're trying to find HF. Now you could think of H as where you are right now. You're at country H and you're trying to get to F. So we're at H and we have to get to F. Now, looking at this diagram, can't really see any way to go to it, right? So you gotta go back to the statement. So it says H, because we're dealing with H. H is such that EF is equal to 3 times EH. So yes, so that entire line that says EF, that is basically 3 times the distance between EH. So if EH is 20 miles, EF would be 3 times 20. But in this case, EH is U, because we're not dealing with any real distance. So we know this entire line is divided into 3 parts, and we know 1. So if we multiply U by 3, we get 3U. So that's the distance for the entire line between E and F. Right, sir?
Yeah, so 1, 2. So it's
Yes.
divided into 3 parts. So yeah.
So to find the entire line, we know one section, which is U. So to find the entire line, we could just multiply by U by 3, which would be 3U. Yes. So looking at this, we see the distance from h to f, which would be 2u. Now, in mathematics, you don't put u and u is distance. I remember we're adding the distances. So we put u plus u. So hf would be equal to u plus u, or
Yeah, AU plus U. Uh-huh.
so in mathematics, we ain't keeping this like this, right? So we gotta simplify it. We gotta simplify this thing, right? So u plus u will be equal to 2u. Good. We don't get 1 mark.
All
Now
right, pause it,
b.
Daniel. Very good,
Mhm.
right? So HF is equal to 2U. So um a key takeaway is Daniel emphasized be very careful with this statement. This statement that said EF, which is from the started line to the end, they told us EF is equal to 3EH. They told us this entire line is equal to whatever this line is, which is U, is equal to 3 of that. From start to end is equal to 3 of that. So this entire line is split into 3. So 1, 2, 3. So U, U, and U. Some people get carried away and they go and say, instead of splitting the whole line into 3 parts, they go and they split this part here and this part here into 3 parts. But no, it's the whole line you got to split into 3. You have to be very careful and look at what the question is saying. That part there, tricks a lot of people. So good. So 2U. Nice and easy one, Mark. Yeah, Daniel.
Yes, yes, yes. So B is MF. So we are at M, country M, and we want to go to country F. And we can't really take the big long distance between them. So we gotta go around. So for example, they got something close down the whatever. So we gotta go around. So I could move from country M to country E. And then from country E to F. But we don't know was ME. So we refer back to our statement. And at the end section, it says M is the midpoint of OE. So in that big line OE, M is the middle of that line. Yes, if you could highlight it. Yes. So in the big line, M is the middle. And if we know if it cut equally, both sides are equal. Like if you get a 100 cm ruler and cut in half, both sides would be 50. So OM is V, and that would also mean that ME is also V. Unless you got some very fancy line. But yeah, middle. So now remember we're trying to find distances around it, right? So we know distances, right? So MF would be V plus. Now we won't put U plus U plus U. We know the entire line is 3U, so we could just put V plus 3U. Yes. So we understand how to do this. Very good. So now let's go to OH. We there? O. Continue.
Well, let me erase these.
Mm-hmm.
Where are you going
It's
from?
bit
OH, O, H or H,
H that
OH.
yeah. H get scratch out. Yes. So we can't take that full distance. We can't take the big long line, the road or whatever closed down. So forget to the country, we gotta go around. So we can go from country O to country M, and then from country M to country E, and then country E to country H. We traveling, right? We traveling. So that distance, OH, will be equal to, we won't put V plus V. We know that's 2V. So 2V plus U. So it's basically just distances. You're trying to find a distance to somewhere. So now we have this mathematics loves to have people show things and prove things. Show that OG, the vector OG, also that line on top of OG is the direction of the vector. Show that OG is equal to 3/5 of 2V plus U. Now, in vectors, what I personally like to do is anytime it says show something, especially a vector, just ignore that statement 3/5 of 2V plus U for now, and let's find OG. Let's find OG for now. So we want to go to O. We want to go from O to G. So what we could do is we can go from O to M, and then M to G, M to G. Yes, but there's a problem. Yes, but see, thing is, sorry, you gotta draw a line, arrow. Yes, yes. Thank you, thank you, thank you. So yes, there's a problem. We don't know what's MG. So like any respectable mathematics student, we're going back to the statement. So it says the point G is such that MF is equal to 5 times MG. Any respectable math students, we are, yes. So okay, so it says MF is equal to 5 of MG. M to F is equal to 5 of MG. Okay, so first things first, we need to actually find MG. So we are told that the big line MF is divided into 5 smaller lines. 5 smaller lines. And each one of those lines is the same distance as MG. So if MG is 5 meters, then all of them is 5 meters. They're equal. Right? So now we try. So now we can't really think, so we gotta go wrong. So we can go from M to E. Right, sir? We're trying to find MG.
Before we do all of Daniel, before we do all of
Mm-hmm.
that, remember we already found, we already thing is you already found MF, right? We
Mm-hmm.
found MF to be equal V plus 3U, right? And it told us that MF is equal to 5 mg. So it's mg we want to find, right? So this
Wait.
entire line here is split into 5 parts. And we
Yes.
know this part here will be 1 over 5 of that piece. This would be 1 over 5. This piece would be 1 over 5. This piece would be 1 over 5. And this piece would be 1 over 5. All right? And all we want is this little piece here.
Mm-hmm.
So we can say mg would be 1/5 of what we found
Of
there, V
that.
plus 3U, right? Now we have all the ingredients.
Yes. We're going to
Finish
bake
off
the
now.
cake. Yes. So that was what I was going to say, but my brain slipped me. I get na call. Yes. So we know MG now. So we're trying to go from O to G. So we know that MG is equal to, so to make it simpler, right? You could write MG as V plus 3U, O, everything over 5. Make it simpler, please.
All right. Let me see
Yeah,
where you're
make
going
it,
with it. V plus 3U over 5. All right.
yeah, because I guess I know some people won't really understand the 1/5.
Mhm.
But yeah, so those two statements mean the exact same thing. So now we know that mg is equal to v plus 3u over 5. We know that to get from O to G, we need to go from O to M. OM is V. So you have to add V plus that. So V plus 3u over 5. So we have a fraction. So to make this simpler, we could put V over 1. Now, to add these two fractions, they are not the same denominator. So what we could do is, because V is over 1, the right side will stay the same. So we could multiply the left side by 5. So multiply the 5 by the V. So V times 5, sir. Yes.
Mhm.
And that would be 5V plus V plus 3U. Good. So we have a nice statement. So now 5V plus V would equal to 6V plus 3U over 5. Now, let me look back at what the question asks. Now we could finally take into consideration, because we know it's OG. So it says, show that OG is 3/5 of 2V plus U. So looking at what we have and looking at that, they look similar, but some different. So we need to find a way to turn this into that. So the first thing that you should be thinking of is factorization. So we could factorize the top of that, the numerator, which is 6V plus U. And we need to find what is common. And what would be common is 3. Right, sir? So it'd be 3, open brackets, 2V plus u, close brackets, and put it all above 5. Now, in mathematics, you can multiply. No matter how you multiply, you will always get the same. So we could write that 3. We could write that 3 as a separate fraction and put it as 3/5. 3/5, open brackets, 2v plus u. Now, if you multiply this across, we know multiplication, you multiply across. So if you multiply this fraction by that, you would get the exact same thing. Okay,
All right,
so now we can move. Mhm.
good. Very good, Daniel. Good. So, folks, and that is how we show OG. As I rightly said, forget about this piece here. The thing about show, when the question says show, we know we're working towards this answer. As I said, as I told you, this is a little ticklish, right? A little tight. A little tight, I won't lie. A little tight. All right. But we basically finding OG and we worked and worked and worked until we arrived at OG. Now, my thing is, if you are a smart student, smart in the sense that you could, you could think, you could outsmart this CXC thing. From the time I end up at here, I know this is the answer that I'm working towards. Then I would just go and write that answer right in this piece. And as a marker, somebody marking, I'll be like, yeah, boy, this child move from here to here, they factorize. But sometimes, you didn't see this. For some reason, you didn't see this piece, but you know this is the answer that you're working towards. So I would just skip this step and jump to this step because I know that is the answer. That is a tricky thing to do. That is a smart thing to do. And you can outsmart the mark and the mark will give you your full marks. All right. So don't be stuck here. Just move to the answer because you know that is where you're working towards. That's what the show thing mean. The show thing means this is gonna be your final answer when you finish. All right, let me finish it off and then have the night and leave the secret to Jar. Well done, Daniel. Well done. Excellently explained. Solid. Solid, right? Solid. So it says prove that OG and H lie on a straight line. OG and H lie on a straight line. Prove that OG and H lie on a straight line. So first thing, I'll come up here. So to prove that OG and H lie on a straight line, we first have to show that two vectors lie on a straight line. But sorry, to show that 3 points lie on a straight line, we need two things. One, they need to be parallel, and two, we need to show that they have a common point, that two vectors, they have a common point. So first of all, let's show that the two vectors that we can form from O, G, and H, that they have a common point. So we see we can move from O to G. We can move from O to G. And then we also see that we can move from G to H. We see we can move from O to G, and then we see we can move from G to H. So because of that, we see that there's the common point G between them, right? So that is the first thing satisfied there. They have the common point G. Now the next part is to show that they are parallel. And to show that two vectors are parallel, which would be OG and GH, to show that two vectors are parallel, one need to be a scalar multiple of the other. So did we find the vector OG? I'm sure with these kind of questions, you will already found OG and GH at some point. So did we find OG and GH? Did we find GH? Did we find GH at any point in time? We found OG. Did we find GH? Actually, we didn't find GH, but we could find GH, right? So let's find OG. We saw that the vector OG. The vector OG is this here. Now let's find the vector GH. GH would be here. So to move from G to H, we see we can go across here. So we can say GH is equal to, this would be 4 over 5. What is M? MG? 4 over 5. What is MF? We found MF. I know we found MF at some point. Yeah, we found MF. MF is right here. All right. So 4 over 5 V plus 3U plus from F to G, from here to here now, we see we are going in that opposite direction. So this will be, instead of plus, it will be minus 2U. And then if you work this out, you'll end up with 4V plus 12U over 5 minus 2U. So this will be the LCM of 5 and 1 would be 5. We multiply this by 1, so this will be 4V plus 12U minus 5 into 1 into 5, that, so we multiply this by 5, this will be minus 10U. Hence, we'll have 4V minus 10U plus 12. I'm rushing it because it's very late. Over 5. Hence, this will be negative 6U plus 12 over 5. And we can rewrite this as, so negative 6U plus 12 over 5. We can rewrite this as 12 minus 6U over 5. And hence we can factorize this and we'll end up with 6 over 5 2V plus U. So we have, I can already see people are lost. So we have these two vectors here, 6 over 5, 2V plus U, and we have this vector, 3 over 5, 2V plus U. And if we look at 6 over 5 and 2 over 5, if we multiply this vector, if we multiply the vector in blue, if we multiply this vector by 2, we'll end up with the vector that we have in pink. Hence, we can say, all right, so I'm writing all over the place. Hence, we can say 2OG is equal to GH. Hence, we can say they are, this is a scalar multiple of each other. If we multiply OG, which is this vector here, by 2, we'll end up with GH. All right? And that is how we can say they are parallel. So let me drag this at the bottom and put the final statement. As I told you earlier, they say a little tight, right? They say a little tight. If you don't understand, if you never did this, it will look like magic, right? You need to understand a lot of things in vector before you understand this. So hence we can say, the vector OG and GH have the common point G, and 2OG is equal to GH. Hence, the points O, G, and H lie on a straight line. All right? To show that two vectors well, 3 points are on a straight line, we have to show that they are parallel and they have the two vectors that you can form have a common point. And that one was very ticklish. I won't lie. Let me see. Yeah. So that there, let me just put this out there. Let me just put this out there. Let me just put this out there. You don't need to know if you found that hard. That won't cause you to fail. That won't even cause you to not get a grade 1, right? You can still get a grade 1, if that is a little tight. You won't fail, you won't even reach to a grade 2. You can still get a grade 1, if you get a 1 wrong. Right? But I won't lie, it's a bit tight, but with that requires a good understanding in vectors. That is probably the hardest thing that you'll find on the paper, right? But that brings us to the end of this live. How was it, folks? How was it in the chat? And my students on the call, how was it? All of you made it to the end, except somebody's missing. Oh, somebody ditched us. Okay. How many person ditched us?
Only one.
Okay. So how was it in the chat? How was it, folks? Did we learn anything? Are we in a better position than we were when we started? And you on my students, how was it?
Yes, sir. School, school.
It was
It was
good.
amazing. It was amazing.
Was
Sir,
amazing.
one.
It
Right.
was okay.
Sir, even though I want to sleep now.
All right. So as I said, I'll leave you with a secret. I always keep to my word. I will leave you a secret about the exam. So the exam, let me leave you with this secret, since all of you stayed here until the end. The mock exam, this is a big secret. The mock exam is on the 16th of March. All right. The mock exam is on the 16th of March.
So shocking,
And the
sir.
big
So
secret is, no,
shocking.
I'm not done. I'm not done. I'm not done. Hold on, I'm not done. And you will have 10 questions in paper 2 and 60 questions in paper 1. And listen to this. It will test the entire syllabus. Yeah, big secret. Boom.
No way, sir.
That's a
Oh my
really
Excellent.
God.
big
Thank you so
So
much
you
for
all
the
stuff,
made
sir.
it, right?
information.
Yeah, made.
Such an amazing secret.
Yeah, 10 questions. All right.
So shocking.
So yeah,
Sir,
so the main thing is you have to stay to the end. Let me see the schools that stay to the end. Drop your school in the chat. Let me see the schools that stay to the end. Represent your school in the chat and then we'll end off. Let me see the schools and then we'll call it George.
Sir, after almost 3 hours of this, of lovely maths, this is an amazing secret. I just want to congratulate you on giving us such a great secret.
Thank you.
It
Thank
was
you.
amazing.
Thank
Over
you.
the top. Applause, applause, applause.
Thank you. Thank you very much. So we have Pretty Noob. We have Saints, Houston, Queenstown, Pretty Noob. Diamond, Potential, NGSS, these are NGSS, North Georgetown Secondary, Myconi, Brigham, Lancaster, Alice from Lancaster, Westminster, 3 Miles, Houston, Vridnoop, Diamond, QC, SL, this one, SLPSS is whereby. Bijival, New Central High, private candidate, all right. Excellent. Brigham, Diamond, Arms, Good Hope, Myconi, Vridnoop, Christianburg, Westdam, Potential, Wakapow, Cottonfield, Houston, Winifred, Endeavors and Commerce, Skeldon, Abramsville, Westdam in the chat, Vridnoop, New Amsterdam, Christ, this is CW, Christianburg, Wismar Secondary, Woodley Park, Vernoop, Yarracabra, Houston, Quarantine, Vernoop, New Amsterdam, Diamond, Skeldon, Queens, PKSS, Camille's, PKSS, HEHE, I guess it's HE. Vernoop, all right. Good. Tutorial, Diamond. Good. Anyway, JC, Nappy, nice. Nappy all the way from
sir,
Nappy. Yeah.
we could get covered. Hmm.
It looked very nice.
Can we?
Anyways, so
Like, can
folks, I
we?
trust that Pastor will be that was just trust that this live was helpful. If you want us to be back, just tell us, follow us, follow on what was the thing? TikTok. Tell us on TikTok, and we'll be back. Probably we'll be back to do another video for the actual CSEC exam. This is for the mock exam. We'll do another one in time for the mock exam. Not the mock exam, the real CSEC. All right. So I trust that this was helpful. Take care, keep practicing. Remember, I moved from 27 to a grade 27% to a grade 1 by simply practicing, right? So it's not impossible. I'm sure most of you got higher than me. So, of course, I was very dedicated, right? So practice, practice, and keep practicing. The easiest questions, the easiest numbers in the paper would be number 1, number 4, and number 1, 4, and 5. Statistics, functions, and number 1. And also algebra is pretty easy. You don't need to get everything right on the paper to pass. All you need would be 4 solid questions or even 3 solid questions and you pass. 3 solid questions and above 50 in paper 1. And we know the secret about paper 1. Paper 1 questions repeat. So somebody kept asking me on TikTok, how do we tackle paper 1? By just practicing them over and over and over. I had a student, by the time she see the question, she already know the answer. So that is the stage you want to be in time for mathematics paper 1. When you see a question, you already know how to work it. And you should be scoring above 50 in paper 1. 3 to 4 solid questions in paper 2. And you go to SBA and you pass at least a grade 2 even, right? But that is how you pass, right? 3 solid paper 1 and SBA. So with that being said, enjoy the rest of your night and keep practicing. We'll see you in the next video. Any message from anybody on the call, on any from my students? Adir, say anything that you say in the video and then we end off, right? Hold on, let me see if I get the end button. Yeah, Adir, say anything that you say in the last piece.